Welcome back to my shed. I'm Paul Hopewell, and this is where I make all sorts of stuff, usually for old classic motor vehicles and machines. And I show you what I went through to finish the project. In this video I'm going to show you what I did to get a digital readout fitted to my lathe and my mill. Starting with the lathe, I needed a DRO because the main slide doesn't have any measurement scale fitted at all. And until now it was all done by smoke mirrors and a lot of guesswork. What I needed was a slide scale that covered 1 metre for the main carriage and at least 300mm for the cross slide. Under normal use, the cross slide rarely exceeds 6 inches or 150mm, but occasionally I need to work to the back of the workpiece, so just to be on the safe side I got a 300mm scale. With all the tools in place and a fistful of slide scales ready, it was time to get some work done. The problem with modern technology is that it's designed for modern machines and not for old machines that are probably rescued from the junkyard by old farts with a few bob in their back pockets. And let's face it, in the 1940s this technology wasn't even a possibility. And to prove a point, on the lathe these scales are going to have to put up with a bit of push and shove to get them true without any twist. And what is more, there isn't much by way of suitable places to mount supports that match the squareness the scale requires. Take for example the back of the main slide. There's a slight overlap where the bottom support plate protrudes beyond the main carriage body. This plate is likely to move under normal conditions, so any sensor support must not come into contact with it. But the main body is not perpendicular, or is there any surface flat enough to accommodate the sensor support. The two faces that you see here are reserved for a taper turning attachment should I get one in the future, so I can't use them. Time to think out of the box again. What I've decided to do is mark and drill the two 6mm screw holes. And I know they're going to be drilled freehand, but I'm going to use a spirit level and a small set square on the longer bolts so that when they're set in place I can bend them as necessary to get them to run as true as possible. You'll see how I did this later on in the video. I shan't show it for every bolt, but you'll get the idea. Now for these two screws, I'm going to do something a bit different. Remember I said I need a perpendicular face to work from? Well, I'm going to use one of those taper attachment faces and a bit of aluminium to provide a base for a bodge that should do the trick. Now, in places that are going to have short screws fitted, I'm not going to be too concerned with getting them perfectly true. Freehand should be good enough. Besides, I'm going to use M6 screws instead of the M4 and M5 screws that were supplied. To help me obtain a perpendicular mounting face, I used some metal resin to help me get the face to work from. I also used a bit of card and petroleum jelly to act as a barrier. Then I nipped it between the main slide and the bottom support plate. Next, I greased up a chunk of aluminium and bolted it to the nearest taper guide face. Two smaller screws were treated with a dollop of petroleum jelly, and then all the nearby surfaces got a light coating. A little bit of tape was stuffed in the end so that I could nudge any wayward resin back into place should I need to. Making sure I was happy with the makeshift moulding arrangements, I mixed up a batch of metal resin and shoved it in the crevice. Well, I did it as best I could without getting it plastered everywhere or becoming firmly attached to the resin mould, if you could call it that. Some time later I started to strip down this makeshift mould and it didn't go quite as planned. It did its job, but not quite as well as I'd expected. The tape and card and aluminium was removed without any fuss whatsoever. To extract the moulded part from the back of the main slide body, I simply undid the two screws and it came away. At first it did feel a bit flimsy, but whilst I was removing the flash and the burrs on the belt sander, I found myself having to push quite hard to achieve the desired results. While I'm thinking about it, the resin I used is called David Isopon's Chemical Metal. I remember years ago when my dad fixed a gearbox cover with it. It lasted a few weeks before it started to leak. After a bit of fettling, this spacer fitted into place beautifully. I used the brackets that were supplied with the scales for now, but I might change them or alter them sometime in the future. I did alter this particular setup a little bit later due to the sensor's distance from the main slide's body, but for now I used it as a sort of levelling device alongside a spirit level to get the scale and the attachment screws set into place. My biggest worry at this time was getting the scale mounted without twisting it out of shape, which was very easy to do owing to the material it's made of and because of its length. Having glass on the inside is another reason that a great deal of care had to be taken. Now that I've marked out the fixing point at this end, I drilled out firstly a pilot hole and then a 5mm tapping hole for the M6 tap. It doesn't take a genius to work out that freehand drilling isn't the best way to drill for a tap because of the obvious flaws, but I had considered this knowing full well that I couldn't tip the lathe up and feed it through the mill. Threading the hole was also a bit risky using a hand drill, but getting the tap started backwards from the other side of the lathe while leaning over it is not for the less energetic or those with a beer gut. The threaded rod was inserted into place and nipped up, followed by another M6 nut and a penny washer. The penny washers will provide a clamping force to either side of the scale supports. These scale supports are 20mm wide by 25mm high, with a 6.5mm by 13mm long recessed slot to allow for any adjustment. These penny washers are key to the adjustments later on. I'm temporarily fitting the outer washer here just so that I can mark out the position for the other end, and I don't want this end to fall off in the meantime. With the aid of a small spirit level and some blocks, I marked out the other end ready for drilling and tapping. Again, it was done freehand, as were almost all the other 6mm tapped holes on the milling machine when I got round to doing that. I did think about potential issues with the use of studs rather than fixing brackets, but then I thought that the studs being used are 6mm rather than the 5 or 4mm as provided. They should be more than capable of supporting a very light scale. While I'm about it, I'd best explain about the studs and how I trued them up. Basically, I bent them true. They weren't far out, but they needed a little nudge just to reduce the risk of distorting the scale. What I did to set this stud was that I used a small set square to either side of the stud from the main lathe bed. Then I used a small spirit level to set the level and then repeated this at the other end. I couldn't actually show you how I did this because it's a bit tight at the back here. Maybe you'll see when I do the milling machine. The penny washers not only allowed me to adjust the height at each end, but the distance from the main slide so that the sensor doesn't get distorted or break the glass within the scale's casing. To set the scale true to the main slide, I used a DTI on a mag mount sat on the main carriageway, and by running it back and forth I managed to set it true in both planes until I achieved better than 0.05mm run out. As there weren't any fitting instructions on these DRO kits, I watched a few videos to get an idea how to do it, and more importantly, what not to do. Another good reason for using studs to mount the scales was that it allowed me to mount the scale covers as well. I cut a piece of aluminium angle to extend one of the sensor support brackets, and after drilling through I bolted it into the top bracket, forming a bridge to the bracket supporting the sensor. But as I pointed out earlier, I'll probably change this bracket, but for now it's got a bit more to do, as you will see very soon. With the sensor support fitted and set, I removed the protective strip, rendering this scale as active. Just to be on the safe side, I ran the main slide back and forth through the full range of movement from spindle to tailstock. All good. Now for the cross slide, and as you can see there isn't much by way of available places to put the blooming thing. Obviously, putting it at the front of the main slide is asking for trouble, but equally putting it at the back of the saddle also has its limitations. Like the problem of using attachments, for instance the follower rest, and where to put the sensor to avoid the fixing bolts. As the sensor couldn't be put between the two main slides, I thought about fitting it on top of the saddle. But I can't put the sensor on top of the main slide because the scale might be too high and may interfere with any future workpiece. And I can't lie the whole thing on its side because the sensor, as far as I'm aware, has to be underslung. I think the thin glass will also bow under its own weight, especially in the longer scales. As I've mentioned before, the cross slide has about 6 inches of normal movement, but occasionally the cross slide has to travel beyond the centre line, so I believe I need the 300mm scale to cope with this, making the sensor very awkward to position. Now there is another issue to overcome, and that's the cross slide body moves inside the follower, often exposing the back end of the cross slide bedway, leaving nothing for the scale to anchor to. The idea I had was to mount the sensor towards the back of the cross slide, meaning that the whole assembly had to be mounted further back as well. However, I sorted this little problem out by using a sample of 25mm section aluminium angle, just to get an idea about a fixing support. The idea was sound and I used a length of steel angle later, but I had to remove a bit of material from both the cross slide and the cross slide cover to allow better access for the steel angle extension. One small drawback was that the aluminium protective cover had to be fitted first, making it harder to true up the scale later. I used a marker here just to remind me to relieve this side of the cover and not the other. After removing the cross slide body, setting it on the milling machine required a few tricks. That was to get the faces that I need milled, but they had to be true to the cross slide and they had to prevent stress on the scale. Trouble is, I can't use parallels to set this top side true. I've got to use a clock or a DTI, and the problem here is that the dovetail on the underside is tapered. Well, one side is, and that's the one that houses the gib strip. Fortunately, there is a way to set the component true using ground rollers, a straight edge, and a couple of engineer's clamps. A while later, I finally got the DTI to read to within 0.01. This corner of the top slide body is being squared to take the steel support. Naturally, I took it steady while cutting these two faces, as there wasn't much holding the cross slide in place. This support had a 6mm hole in it that I later utilised. But first it was necessary to position the two countersunk side screws so that they don't break through into the dovetail, or the bolt hole. Both of these 6mm tapped holes are 50mm apart. This outer radius is being cleaned up to accept the support block, and like the scale support, it had to be true to the cross slide. Later on, this 6mm tapped hole needed to be better positioned than this because I altered my plans. Still, it's done now and I can't change it. The steel scale support was drilled to fit the hole pattern on the side of the cross-slide body. Before going too far, I did a trial fit to ensure that the holes lined up. And once I was happy with the result, I countersunk the holes to make the final fixings flush. Using the existing 6.5mm hole in the support bracket as a guide, the 6.5mm drill was used to dot the slide body before changing the drill to a 6mm tapping drill. I was very cautious while drilling this hole that I didn't drill into the existing hole below. Now that I've done the cross-slide modifications, it's time to reassemble stuff. I nearly forgot this small modification. I had to use the linisher here because I couldn't hold it in the mill without using a million clamps. And who likes using a million clamps? I did change this 6mm cap-head screw for a countersunk screw a little bit later. I had to, it wouldn't go underneath the steady. At this point I'd just discovered a problem. When I fit the scale, the index dial won't be used. With the index wheel screw removed, the cross slide retracts a further 40mm out until the cross slide hits the hand wheel. And because I don't want this extra movement to damage the scale or sensor, I'll have to make another modification to what was supposed to be a simple spacer block by making an offset spacer block that accommodates for the extra 40mm. So I'll need to make something like this from this. This new setting block was cut to shape using my Strassman style roughing cutter. It's about due for sharpening along with many other cutters and even more drill bits. That's something that'll have to be done in the not too distant future. After a drop of fettling, I blued up for a spot of marking out. This is for one through hole at 6.5mm and for one tapped to 6mm. The through hole is 5mm from the top face, the other is 15mm lower and 40mm to the right. I only run this tapped hole down to 20mm depth. After a quick wash and brush up, it's ready for use. When I drilled this block, it had to bolt in place so that it was just shy of flush to the compound slide face, thus preventing any collision issues. I just had to confirm that there was plenty of room around the scale before I went any further. This is where I had to modify the chip guard because it was 8mm too tall. I've got another job for the chip guard before I bolt it on, and that's to use it as a sort of trammel bar. That's instead of using the scale to do the next bit of marking out. All I had to do was mark out and drill 2 holes to match the scale supports, then make a bolt-on scribe. The bolt-on scribe is nothing more than a bit of threaded rod sharpened at one end. Then, when bolted on, we'll span a gap to mark out a point equal to the scale's length. This bit of shaped aluminium bar was screwed to the end of the scale support as a direct result of altering the scale's position by 40mm after cutting the bar to size. As I've used up the last of my small angle steel, that was the only option I had. However, it did come in handy for setting the scale later. Anyhow, this is what I meant by using the chip guard as a trammel bar. The threaded rod was bolted onto the free end and adjusted to simulate the scale's final fixed position. Then, after scribing the extended support, it was slotted out to allow a degree of vertical movement. It was then I had the idea that made this small extension more useful. That was, what if I fitted a long screw through from the bottom to act as a jacking screw, assisting me to set the scale later? Having approved the idea, marking out operation and subsequent drilling and tapping operation was performed, and the jacking screw was inserted after the thread end was polished to make the jacking operation as smooth as possible. Obviously this end had to be the pivot, and the other end had the task of setting the height and parallel. For this I needed a bit of threaded rod long enough to secure the scale and allow final trimming. The compound slide does just catch the chip guard a little right now, but that clears itself after the scale has been trued up. Truing up the cross scale was a lot easier using the jacking screw, and the good thing is that the jacking screw doesn't have to remain there. Once the scale was set true, all the screws were snugged up and the plastic end caps were fitted. The nearest end cap had to be modified just a little so as not to cause problems with the compound slide. I took the follower rest off for two reasons. One, because I'm not using it, and two, because, well, just to show you that I can do so without disturbing the scale. I had to resort to a bit of butchery here in order to get this bit of bracketry to support the sensor. It took a couple of 6mm socket screws to attach it to the other brackets and two 1mm thick washers to attach the bracket to the sensor. Now that the sensors and scales have been fitted into place, all I had to do was plug in, switch on and go through the startup procedure. But before I did that, I couldn't resist having a quick waggle on the hand wheels. I know the sensor support bracketry is a bit Heath Robinson, but I do intend to make a purpose-built support soon. There we are. I hope my effort to fit a DRO to my lathe was, well, entertaining, as I hope the video about me doing something similar to my milling machine in part 2 will be. Thanks for watching. See you next time. Bye for now.